Hi everyone, welcome to the second part of the 7.4 notes. If you're joining me right now, you want to have your 7.4 notes open, and we've completed the first part of the notes in class. This is part 2. And so I'd like you to then flip ahead, starting at the first page of 7.4, flip ahead to the fourth page of the 7.4 notes. And you'll see at the top of the fourth page that you have this example here. You have a parabola, and it says write the quadratic function in factored form. So we're on the fourth page of the notes, and we're going to start our lesson right here. This is 7.4, part 2. And in part 1, we looked at how to write, if we're given a graph, how do I write the equation for that quadratic function in factored form? And I'm just going to remind you for a moment then that factored form looks like this. Okay, factored form is y is equal to a, and then we write the trinomial, okay, or the remainder of the function as two factors, x minus r and x minus s. Okay, this is factored form right here. So if I have a graph like this, the first thing I recognize is that my roots, or my x-intercepts, are the points where this parabola crosses the x-axis. So here's one point right here where I see that my parabola crosses the x-axis. That is the point x is equal to -2. So I can call this could be my r. Okay, and I see my other x-intercept over here is at x equals 1. And there's my s. Okay, it doesn't matter if I label -2 as s and r as 1. Either one is correct. So those are my roots. So I have identified my two roots. My roots are r is equal to -2, okay, and s is equal to +1. Those are my two roots. I can substitute those values right away into my factored form equation. Okay, so far I have in factored form y is equal to a. I don't know what a is yet. I don't know what that coefficient a is. I have to solve for that. But I do know that r is equal to -2. So I'm going to write in here x minus r. Well, x subtract r. R is -2, so I'm going to put a -2 in right there. Okay, multiplied by x minus s, and s is 1. So I want to clean these two brackets up a little bit, so I'm going to rewrite this as y is equal to a. I can see that subtracting a negative will give me a positive value. So minus -2 is the same as +2, x plus 2. Okay, and x minus 1 can't be simplified anymore. So there we go. So I've won half the battle. The only thing I have to solve here is I need to figure out what is the value of a. I need to find this. So there's my first step. I've used my roots, and I've substituted them into the factored form. The second step is I need to choose a point from my graph, okay, and substitute it into this equation to solve for a. So I'm going to solve for a, okay, and I'm going to use a point. I'm going to use a point that will be easy to substitute into my equation, and I also want to choose a point from my graph here that is very easy to identify the coordinates of the point. The y-intercept is one of the easiest points for us to use. This is the y-intercept. It's the point where the parabola crosses the y-axis. So this point right here, which has a coordinate x equals 0 and y equals -3. This is the point 0, -3. This is going to be the point that I use. You could use another point if you want to, as long as you have easily read coordinates. Okay, so for example, this point right here might be another good point to use. I see that that's the point -1, -3. I can clearly see the coordinates of that point because it falls right along a grid line. So that would be a good point to use. This point right here would not be a good point to use because I have to estimate the x value here. I can see that this point is -1 for y, but I'm not too sure what the x coordinate would be. It looks like it's somewhere in between -2 and -1, and I'm making a guess. I don't want to make any guesses here because a small error could lead to the wrong value of a. So you need to use a point that's very easy to read right off your graph. And the y-intercept is always a great point to use for two reasons. One, it's easy to see. The second reason is that the x is equal to 0 at this point, and so that is going to make my substitution a little bit easier as well. So let's do this. Okay, we're going to use the point 0, -3. I'm going to plug in x equals 0 and y is equal to -3 everywhere that I see an x and a y in my equation. Okay, so I'm using the equation up here. This is the equation I'm using. I'm going to plug in a -3 for my y instead of a y. Okay, that's equal to a. Instead of an x, I'm going to put in a 0 because I'm substituting in this point, 0, -3. Okay, plus 2, again, another 0 for the x, -1. Okay, let's tidy this up. I can do the I can do the subtraction and the addition that are in the brackets. So I get -3 is equal to a. Let's do the math inside the brackets. 0 plus 2 is just 2. 0 minus 1 is simply -1. I can put these together on the right-hand side. I see that a times 2 is 2a, times -1 is -2a. Okay, and that's equal to -3. So I want to solve for a. I'm going to divide both sides by -2 because I want to isolate a. I need to also divide the other side by -2. So my answer is a is equal to, I have a negative and another negative, a negative multiplied by a negative, which gives me a positive value, +3/2. Okay, I can pretty much get rid of that negative, that positive sign, because that's the same as writing 3/2. Okay, but I notice that a negative times a negative, or a negative divided by a negative, gives me a positive. So there's my value. A is equal to 3/2. I could write this as a decimal. Okay, A is equal to 3 divided by 2, which is 1.5, 1.5. Both of these are totally acceptable. Okay, I just happen to like to use decimals. Okay, sometimes it makes math a little easier when we have decimals. So, but either of those would be correct to use. So I can now rewrite my equation in factored form. Now I know the value of A, and so here's what I have. My answer is this. Factored form. The equation of this quadratic in factored form is y is equal to 1.5 for a, x plus 2, x minus 1. Okay, remember that what you're trying to do when you write your equation in factored form, looking at the top of your page for a moment, you're trying to get it in factored form, which looks like this. Y is equal to a, which is a number, x minus r is a number, x minus s, and s is a number. So there, I've done it. There's my factored form. Excellent. And from that, I could immediately recognize the two x coordinates, or the two roots. Question B asks us, what is the equation of the line of symmetry? Well, remember that the axis of symmetry, if I look at my parabola, go back to your graph for a moment, I know that the line of symmetry, or the axis of symmetry, is going to run right through this parabola, right through the vertex, and it's going to divide my parabola into two equal symmetrical halves. It looks to me, if I were to look at it, like my line of symmetry is, it looks like it runs somewhere in between 0 and -1 on the x-axis. Okay, it looks like it's right about there, and so it looks like about -0.5. But I can check this by using my two roots. I know that the axis, or the line of symmetry, is exactly halfway between -2 and +1. It's exactly between my two red dots, which are my two roots for this quadratic. And here's the formula that we have for the quadratic, or pardon me, for the axis of symmetry. The axis of symmetry, x, okay, is equal to r plus s divided by 2. We're going to add the two values for the x-intercepts or the roots together and divide it by 2 because it's exactly halfway between them. Remember that r, from our graph, we said that r was equal to -2, and s was equal to 1, +1. So those are the values that I'm going to put into my formula here. So I have -2 for r plus +1 divided by 2. -2 plus 1 is -1 divided by 2. -1 divided by 2 is -1/2, or -0.5 if I express that as a decimal. There's my answer. So my axis of symmetry is the line x is equal to -0.5. That's the line, the vertical line that runs right through my parabola, and it splits the parabola into 2 equal parts. So going back there for a second, I eyeballed it. I said it looked like it was around -1/2 or -0.5, and I am correct. So I can label it right now. There's my axis of symmetry. This is x is equal to -0.5. Perfect. Finally, the last question, C, says, if I didn't know the value of C, imagine that I didn't have a graph. I do have a graph, and I could look at that graph and I can see clearly where that parabola crosses the y-axis. Okay, I can see the y-intercept. But if I didn't know, I could use the factored form to figure out what my y-intercept is. Remember that C is simply the y-intercept. This is the point on the parabola that crosses the y-axis. So at some point, 0 for x, okay, y, or C, okay, some value for C. And if you go back for a moment and just look at the top of your page, okay, you can see that it crosses the y-axis right here. Here's the y-axis. Okay, it crosses at the point -3, 0. So I can see that from my graph, but if I didn't know that, I can use factored form to determine it. Again, my factored form is y is equal to positive 1.5. This is factored form. Okay, x plus 2, x minus 1. Okay, there's my factored form. And in the beginning of our notes, we were given a little bit of a trick, okay, or a little formula to remember. And here was the formula. C is equal to, if you don't know C, it's equal to the sum of A times R times S. Okay, there's my formula. And so in this case, A is equal to, well, here's my A. A is equal to 1.5. Okay, my R is equal to -2, and my S is equal to 1. So I could simply do this as 1.5 times R, which we said is -2, okay, times 1 for S. And so if I use some multiplication to solve that, 1.5 times -2 times 1 is -3. Okay, there we go. C is equal to 3. So I know that the y-intercept, oopsies. Oops, sorry you guys, I think I've just lost my lost my pen for a minute. C is equal to -3, and so the y-intercept is the point 0 for x, -3 for y. This little formula right here is c equals a times r times s. It's just a shortcut. If we don't have a graph and all we have is factored form, we can find c. Okay. Let's do another example. It says for each function that is given in factored form below, determine the values of r and s, or the x-intercepts, determine the value of a, determine the y-intercept c, and determine the equation of the axis of symmetry and the coordinates of the vertex. So use the factored form to solve for just about anything that we could be asked for this graph. Okay? So let's start with the x-intercepts, the roots. If I'm given a factored form instead of a graph, I just want to remember what factored form is. So over here, I'm just going to write it out. So I'm just going to remember that factored form, and you will be provided with this equation. Okay, factored form is y, or f of x, is equal to a x minus r x minus s. Okay, where r and s are the roots, or the zeros of the parabola. Okay, so when we have a look at this, then I'm looking for r and s. I'm going to rewrite this equation so that it looks exactly like factored form. Okay, so I'm going to rewrite this like this. I'm going to write factored form underneath it. So I see that it's going to be equal to a, okay, times x minus r x minus s. And if I were to have a look, then I see that if x plus 2 is going to be written as x minus some number, I see that that number is going to have to be negative 2. X subtract negative 2 will give me x plus 2. Okay, I'm just rewriting this in factored form below, and I see that x subtract negative 2 will give me x plus 2, because a negative subtract another negative, pardon me, and two negative signs together give me a positive sign. So I can see right away then my r is equal to negative 2. And if I compare x minus 3 to x minus s, I see that all I have to do is put a 3 right there for that to fit into factored form. So I see that my s is equal to 3, positive 3. Okay, so those are my two x-intercepts. Another way that I could write this, okay, so the roots are x equals negative 2 and x equals negative 3. The other way I could say this is I could also express these as points. This would be the point negative 2, 0, and the point, sorry, positive 3. I need to just fix that, please, folks. That should be a positive 3. Sorry about that. Okay, the point 3, 0. Good. So from factor form, I can find my x-intercepts, or my roots. The value of a, if you compare factored form, the red equation that I've written, to the equation above it, I see that a is simply equal to 1. Okay, there's a little 1 right here that has not been written in, okay, but a is equal to 1. If I don't see another number there, then I know a is equal to 1. If there is another number there, like a 2 or 3, then a is equal to whatever number it is I see in front of the brackets. But if I don't see any number, then I know that a is equal to 1. The y-intercept. You have two choices here in terms of how you want to solve for the y-intercept. Remember, the y-intercept is c. So when we write out factored quadratic in standard form is this: y is equal to ax squared plus bx plus c, where c is my y-intercept. It's the point where the parabola crosses the y-axis. You have two methods of solving this. You could take your factored form, which is y is equal to x plus 2 times x minus 3. You could expand that and and change it into standard form if you wanted to, and simply then just look and see what's the value of C. Okay, you can do that. Or you can take the shortcut, which is to use the formula C is equal to A times R times S. Okay, C is equal to A multiplied by R multiplied by S. And sorry, this should be a equal sign right there. Okay, so C is equal to A, which we determined as 1. Okay, 1. I'm just going to, sorry folks, I just need to fix my pen really quickly. Sorry about this. Sorry everybody. Just having a few problems with my pen. Okay. Okay, let's go back here to our question for a second. So if C is equal to A times R times S, so fix that A, where A is 1, R I determined to be -2, and S I determined to be 3. Well, let's do that math. 1 times -2 is -2. -2 times 3 is -6. Okay, so C is equal to -6. In other words, my y-intercept is the point 0 for x, -6 for y. Okay, there we go. The axis of symmetry, I'm going to give myself just a little bit more room here and we'll deal with the vertex in a moment. The axis of symmetry is simply the point of, in this parabola, where I can divide the parabola into 2 equal parts. And I know that my axis of symmetry is going to run directly in between the 2 x-intercepts, or the 2 roots. So I have this formula: x is equal to r plus s divided by 2. This is my formula for the axis of symmetry. So again, I simply plug in the values of r and s that I know. So I know that r is equal to -2. So -2 plus 3 is r plus s divided by 2. Let's go ahead and do that math. -2 plus 3, it's the same as 3 minus 2, which is 1, over 2 is equal to 1/2, or 0.5. So my axis of symmetry is the line x equals 0.5. So my axis of symmetry is the line x equals 0.5. And if I had a graph of my parabola, I could draw my axis of symmetry as a vertical line right through x equals 0.5, and it would split my parabola into 2 equal parts. Knowing that, okay, I also know that on my parabola, if this is my parabola, and I know that it has an axis of symmetry that runs right through the center, okay, if this is my axis of symmetry, x equals 0.5, the other thing that I know about a parabola is that the vertex lies on the axis of symmetry. So my vertex is going to have the coordinates, x will be 0.5, okay, and we just want to find out what is y going to be. What is the y coordinate of my vertex? I know that my vertex lies on the axis of symmetry, so I know it has the coordinate 0.5 for x. So on your notes there, just one second folks, I'm just going to get myself a blank page here. Okay, so on your notes for the vertex, here's how we will solve for the vertex. So this is for section, the last section, the vertex coordinates. Okay, so I know that the vertex has the x coordinate 0.5 because the vertex lies on the axis of symmetry. Okay, so because it lies on the axis of symmetry. So what I'm going to do then is I'm simply going to substitute in x equals 0.5 into my equation. So I'm going to substitute x equals 0.5 into the factored form of my equation, and I'm going to solve for y. I want to see, well, when x is equal to 0.5, what is y going to be equal to? So I am going to say, and we can write this in function notation, would be f of 0.5. Okay, that's the same as saying y is equal to, that's the same as y. F of 0.5, let's put 0.5 in everywhere that we see an x. Okay, before I do that, I'm just going to quickly write then, here is my factored form. I had y was equal to 1, okay, x plus 2, x minus 3. There's my factored form. I'm going to simply put in a 0.5 everywhere I see an x. Okay, so that's going to look like this. 1, 0.5 plus 2, 0.5 minus 3. All right, let's clean up what we see in the brackets. 0.5 plus 2 is 2.5. Multiplied by what I see in the second bracket. 0.5 minus 3 is negative 2.5. Okay, so now I have y, okay, is equal to 2.5 times negative 2.5, which is going to give me negative 6.25. Okay, that is the y coordinate of my vertex. So my vertex is the point. Okay, my vertex is the point. X is 0.5. And the y coordinate of the vertex is 6.25. There is my, negative 6.25. Okay, there is my vertex. Anytime you have to find the vertex, you know it's on the axis of symmetry, so you use the value of x, okay, everywhere on that axis, and you substitute that value of x into your equation. And you will come out with a value of y, and that value of y is the y coordinate for your vertex. Okay. Let's do one more question here. I wanted to give you one that's slightly different. Here you see f of x, which by the way is the exact same as y, equals 1 minus x plus 4. Remember that f of x is just function notation. It's just another way to write y. Okay, I have this equation here, and I want to use this equation in factored form to find all of the same things that I did in the last example. The thing that I notice about this is that I see that this is written a little bit differently. It's out of order. Factored form looks like this. Factored form is y is equal to a x minus r x minus s. In factored form, the factors always begin with a positive value of x, subtract r, multiplied by a positive value of x, subtract s. I always see that x comes first when it's written in factored form, and it always has to be a positive value of x. So what I want to do is I simply want to rearrange or rewrite the factored form that I'm given in my question so that x comes first. And that's just as easy as switching around the order of the 1 and the negative x here. Okay, I'm just going to switch these around. I'm going to put the x first and put the 1 at the end. Notice that the x has a negative or a subtraction sign in front of it, and I have to keep that negative sign with the x. So I'm going to rewrite this as y is equal to negative x, okay, plus 1. It's a positive 1. I'm just putting the 1 after the x, and this is the exact same thing, okay, multiplied by x plus 4. I don't need to do anything to the second factor in brackets. It looks fine. When I compare what I have just written to my factored form in red over here, I see there's still a problem because x always has to have a coefficient of 1. It has to be a positive x when it's written in factored form. And here I have a negative x. So what I'm going to do right here is I'm going to factor out, I'm going to factor -1 out of the first term, or the first set of brackets there. If I factor out a -1 from the first term, if that was my greatest factor, okay, for the first term, if I factor that out, I see that I'm left with x minus 1. Okay, multiplied by x plus 4. So again, I don't have to do anything here to the last term. It was fine. So now just have a look at that. If I wanted to work backwards and do a really quick check, if you do a quick check of how you factor this, if I did a quick check and I said, okay, let's just multiply that -1 back in. Okay, let's just expand this and see. I'll just check. That would give me negative x. -1 multiplied by -1 is +1. So that would give me this again, which is exactly what I had. Okay, so I don't have to always do that check. I could even do it in my head, but it's not a bad idea just to confirm that yes, indeed, I have factored that out correctly. Okay, so I've rewritten my equation now in factored form. Okay, done. Now I can solve for the x-intercepts, and I can also solve for a. The first thing I notice here is that a, here is a. I see that a, the number in the front, is equal to -1. So I could solve for that right now. A is equal to -1. Write that really clearly. A is equal to -1. Okay. The other thing that I can see right away is I can solve for my values of r and s. I know that r, okay, is right here underneath, and I see that s, okay, is going to be in my second bracket there. When I compare it above to factored form, x minus r, x minus 1, r is equal to 1. Okay, on the second one there, I see that in factored form it should be written as x minus s. And so if I want to write this as x minus a number, okay, I see that it must be x minus -4. X minus -4 gives me x plus 4. So I know that my s is equal to -4. Okay, so there are my two values. My two x-intercepts are, and I can write this as r is equal to 1, okay, and s is equal to -4. Those are my two roots, or my two x-intercepts. It's also valid for me to say x is equal to 1 and x is equal to -4. Okay, there's more that we can also write our x-intercepts or our roots as x equals some value. Okay, the letters r and s are just letters that we use here for factored form. Okay, it's also correct to state x equals 1 and x equals -4 are my two x-intercepts. The y-intercept for this, for this factored form here is going to be c is equal to a times r times s. Okay, so I can put in the values that I have for a, r, and s, and I can figure out what the y-intercept is. So a is equal to -1. Multiplied by r, which is 1, multiplied by s, which is -4, and I get -1 times 1 is -1, -1 times -4 is +4. So c is equal to 4. There is my y-intercept. So my y-intercept is the point 0, -4 on the parabola. The axis of symmetry, I just have to give myself a little bit more room here, folks. The axis of symmetry has the formula x is equal to r plus s divided by 2. I know that r is equal to 1, s is equal to -4, divided by 2. Let's clean that up a bit. 1 plus -4 is the same as 1 minus 4 over 2. 1 subtract 4 is -3 over 2. That negative can come out front, and 3 divided by 2 is 1.5. So I have negative 1.5. Okay, so I can rewrite this nice and clean down here. So x is equal to negative 1.5. That's my axis of symmetry. Perfect. All right, excellent. Finally, my vertex. Okay, my last point here. My vertex, I know my vertex is going to lie on the axis of symmetry. So I know that my vertex has the x coordinate x equals negative 1.5. So I'm going to plug that value of x into my equation for my parabola. So I'm going to plug that into y is equal to -1, x minus 1, x plus 4. Okay, I'm going to plug in negative 1.5 everywhere that I see an x. So I'm going to substitute in negative 1.5 everywhere that I see an x, and I'm going to solve for y. Okay, let's go ahead and do that. I'm just going to give myself a little bit more room here. Just a moment, folks. Okay, so this is what I have. Okay, y is equal to -1. Instead of x, I'm going to write in here negative 1.5 minus 1, negative 1.5 plus 4. Okay, and I go ahead and I'm going to solve now. Okay. Inside the first bracket, negative 1.5 minus 1 is negative 2.5. And in the second bracket, negative 1.5 plus 4 is the same as 4 minus 1.5, which is simply 2.5. Okay, positive value. And so I have -1, negative 2.5, 2.5 times 2.5 is 6.25. So I get a negative times a positive gives me a negative 6.25. Okay. And I still have this -1 out in front, which is going to make my value positive. So I have y is equal to 6.25. So my vertex has the coordinates, or is the point, negative 1.5 for x and positive 6.25 for y. And I'm done. So factored form gives us an awful lot of information. It tells us what the roots are. It allows us to immediately see what the value of a is. It also allows us to find the axis of symmetry, the y-intercept, and the coordinates of the vertex. I'd like you guys to try questions on page 391, number 1, number 2, A and C, number 3, 4, and 11. And check your answers in the back of the textbook and make sure you're doing it correctly. And that's the end of our 7.4 notes. And you can join me for 7.5 notes, which deals with factoring. Thanks for joining me.